Hi there, another vintage Fluke meter. This time a Fluke 27, and it has definitely been through a lot. There are cracks, and the top, including the display window, is partially covered in some kind of hardened glue. The rest seems in reasonable shape. Let's see what it says on power on. It's definitely not very happy. Just about any function results in a flashing overload. Now here's a thing I discovered by accident. I think the established term is percussive maintenance. Let's see how successful this was. It should read plus 5 volts, so that's no good. Maybe more maintenance will help? Different, but still wrong. And negative. And swapping the leads makes it more negative? I tried a few other things, but none worked. Especially interesting is negative resistance when shortening the leads in the ohms range. Let's dive right in. I'm shortening the whole opening sequence as it's exactly like for the Fluke 25 I fixed a while ago. At least there are no bent pins this time around. Because the display works, the problem is unlikely to be on the display board, so let's get the shields off the analog part. The analog PCB does not look too bad. Considering the cracks we saw earlier, indicating maybe a drop from considerable height, I was kind of expecting loose components, but nothing of that sort. It's interesting to see how Fluke improved the circuit. My Fluke 25 of the previous video was using an earlier version. The fusible resistor that caused the trouble in the 25 has been replaced with a normal one in series with a thermistor. Definitely a good idea. Also next to the fusible resistor was a beefy 220K carbon composite resistor, which is now a sleek resistor on a ceramic substrate. Okay, enough of that and on with the job. If there's nothing obviously wrong here, it seems prudent to check the soldering for cracked joints and the like. Oh, and there's an immediate suspect. Have you spotted it? It's there on the lower right. Rather heavy corrosion on two soldering joints next to each other with some bluish residue in between. That could be conductive and causing a short. I'm using a fiberglass pen to get rid of the residue, which took a bit of time. Then cleaned it with isopropyl alcohol and then resoldered the two solder joints for good measure. Also, the isolated side of the shielding at that position had residue on it that needed cleaning. I suspect some moisture got into the meter and caused this corrosion. To see if all the cleaning fixed the problem, I put the meter together temporarily without shielding. Success! That corrosion problem was the cause of the erratic behavior. A quick functional test. DC volts is fine. Continuity works. Diode test works, with a Fluke typical short beep when the voltage is in the ballpark of the forward voltage of a silicon diode. Resistance works too. The corrosion was between pin 1 and pin 2 of this op-amp, a Maxim ICL 7611. Pin 2 is the non-inverting input and pin 1 is part of the offset compensation. As this snippet of the Fluke 27 schematic shows, Fluke has left pin 1 and pin 5 floating, which is consistent with the fact that there are no PCB traces going to pin 1. The crystals formed by the corrosion created a somewhat conductive path between pin 1 and 2, messing up the offset and causing weird effects. Giving the meter a good jolt, rearrange the crystals ever so slightly, changing their resistance. The milliamp test is not working. When bridging the Fluke, the blue meter shows about 40 milliamps of current is flowing, and using the amp socket instead of the milliamp socket on the Fluke shows the same 40 milliamps. This fault points to a blown milliamp fuse. I already mentioned in my Fluke 25 video that it has 3 fuses, 2 are in series for the milliamp range. Fluke revised this circuit, and so this Fluke 27 has just the usual 2 fuses. Yes, this fuse is blown. The milliamp fuse is a high rupture type, 1000 volts 440 milliamps, which are quite expensive, but for your own safety you should always replace it with the correct type from a reputable source. Yes, as expected, with a replaced fuse the milliamp range now also works as it should. With the meter electronics now working, it's time to think about the messed up exterior. My plan is to maybe remove the whole display window and replace it with a piece of clear plastic scavenged from somewhere. To gain access, the digital PCB has to be removed. I'm really glad that the thing came out as one piece. In particular, that the LCD and its zebra strips stayed attached, because aligning these together when reassembling is something I was not looking forward to. There's a black frame which can be easily removed. Examining and probing the display window established two facts. Firstly, it is glued very firmly into the housing, and trying to break it out will likely damage the already cracked housing. And secondly, it is made of unusually thick transparent plastic. Both of these facts are likely because the Fluke 2X series, when new, were hermetically sealed, waterproof and ready for use in explosive atmospheres like in mines. The thickness of the window suggests that maybe hard polishing is an option, essentially removing the whole messed up top layer with all that glue and scratches. I started with polishing compound, but quickly resorted to sandpaper, and that still took me an hour of work. That got rid of the glue, and now using polishing paste makes sense to get rid of the scratches left by the sandpaper. Another hour of using gradually finer polishing paste. In case you are wondering, I was using Novus scratch remover. I'm not sponsored and bought this myself. Maybe other pastes work equally or better. I can't say because this is the only brand I have, but I'm quite satisfied with it. That looks a whole lot better. I also applied drops of glue to the cracks at the four corners. My guess is that this is where the moisture got in that caused the corrosion. This looks so much better than before. Okay, the yellow housing around the display is still a little rough, but that doesn't really bother me. An easy readable display is what I do care about. The camera can hardly do justice to how much better this display now looks. Almost new, very happy with that. I tested the accuracy of the Fluke 27 and it met its spec, so I don't bother you with it, but sometime later I decided to do a calibration, similar to what I did for the Fluke 25. Everything apart from AC volts is just one step. Apply 27 volts DC and adjust that trim pot until the display reads 2.7. That part is easy enough, but as with the Fluke 25, I find it difficult to get tools that actually work with the trimmers in the Fluke. The first AC volts calibration is to apply 27 volts AC at 100 Hz. That is relatively simple, as any decent function generator can produce that, and you can use a known good meter to verify the voltage. The next step is to apply 270 volts AC at 10 kHz. That is tricky. One way is to use my vintage Genrad audio oscillator that has enough current to power a transformer to get the 270 volts, but the output voltage cannot be set exactly to 270 volts, and as the oscillator warms up, it does change. One of these days I make a video about this baby. Adjusting this was tricky, not at least because of the high voltage, but in the end I managed to get it to the voltage displayed on my Agilent 3441A. Calibrating the 27 volts AC at 10 kHz is very similar to 270 volts, except that I don't need the transformer because the Genrad can handle this voltage easily alone. The trouble is really with the Fluke trimmers, which I find extremely difficult to operate with the tools I have. Finally, back to 2.7 volts, but now at 10 kHz, which was really quite a bit out. This voltage again comes from a function generator and is therefore exact and stable. Because this one was relatively far out, I decided to run the bandwidth test again, and the range from 2 kHz to 60 kHz is now much flatter, a nice improvement. A quick reminder, the Fluke 25 and 27 are only specified for 30 kHz, so that hump at the far end can be ignored. And that's it. I recommend watching my repair of the Fluke 25 if you have not seen it. It covers a few things that I skip here. The Fluke 25 and 27 are identical in their specs, but the 27 has the rel and min-max buttons missing on the 25. As multimeters go, Flukes are pricey, even used ones. Used Fluke 25s and 27 are not so much in demand and more affordable, especially if they are sold as being defect. As you saw, as long as the display works, there's a fair chance that they are repairable. If you enjoy my videos, don't forget to like and subscribe. There are many more projects, repairs and reviews coming up, and it would be great if you decided supporting this channel by becoming a Patreon. Thanks for watching.